Yo, it's me, Hopi Gaming, and today we are going to talk about engineering data analysis topics, specifically hypothesis testing, linear regression, and correlation coefficient. So first thing that we are going to talk is hypothesis testing through a z-test. I have example problem here. A factory has a machine that dispenses 100 milliliters of fluid in a bottle. An employee believes that the average amount of fluid is not 100 milliliters. Using 40 samples, he measures that the average amount dispensed by the machine to be 98 milliliters with a standard deviation of 2.5. A. State the null and alternative hypothesis. B. At a 95% confidence level, is there enough evidence to support the idea that the machine is not working properly? So first thing that we're going to do is we have to state the null and alternative hypothesis. So in the problem, our null hypothesis is equal to 100 and our alternative hypothesis is not equal to 100. So next thing that we are going to do is first we are going to determine what type of test we are gonna do, if it is one-tailed or two-tailed test. Since our HA or our alternative hypothesis is not equal to 100, this means our value could could be more than 100 or less than 100. So we are gonna use two-tailed test. So this is a two-tailed test. So this is our curve. So as you can see from the right and from the left. So this is the shaded region. So or the rejection area. So if our z value falls under the shaded region, this means that we are going to reject our null hypothesis. So with a 95% confidence level, our critical value is 1.96 to the right and to the left. So we have to take note our given. So we have a x bar of 98, standard deviation of 2.5, the sample n is equals to 40. So using the z value formula, we're going to calculate the z value. So z is equals to x bar minus the hypothesized mean or mu sub 0 over s over the square root of n. So plugging in or substituting the values. So x bar is 98 minus 100 over 2.5 over square root of 40. So using our calculator, this is approximately negative 5.06. Since negative 5.06, it belongs here to the, the shaded region or the rejected area. This tells us that we should reject our null hypothesis. So we could say that with a level with a 95% level of confidence, we cannot accept the null hypothesis that the average fluid dispensed by the machine is 100 milliliters. So at 95%, we conclude that the machine is not working properly. So you can see here, so our decision is to reject the null hypothesis. So our conclusion, the sample data support the claim that the average amount of fluid is not 100 milliliters. So next thing is linear regression and coefficient correlation. So first is linear regression. So linear regression attempts to model the relationship between two variables by fitting a linear equation to observed data. A linear regression line has an equation of the form y is equals to a plus b x, where x is the explanatory variable and y is the dependent variable, or the slope intercept form y is equals to mx plus b. So this is a picture of a simple linear regression, and I have a problem here and we are going to solve it. So we are going to write a linear equation that best fits the data in the table shown below. So we have the x column and the y column. So 2, 4, 6, 8, 9, 10, 12, 14, 16, 18, 20, 3, 6, 9, 12, 15, 18, 21, 24, and 27. So first thing that we are going to do is to add columns, two columns, which is for the x and y and x squared column. So X and Y, you're just going to multiply X and Y. So 2 times 3 is 6. 4 times 6 is 24. 6 times 9 is 54. 8 times 12 is 96. So on and so forth up to the last number. 20 times 30 is 600. Same here in the x squared column. You just have to square this x. So 2 square is 4. 4 square is 16. 6 square is 36. 8 square is 64, and so on up to the last value, which is 20. Square is 400. And then we have this summation or the total row. So summation of x is 110. Summation of y is 165. Summation of xy is 210, 2310. And summation of x squared is 1540. So next is we're going to write the equation. So y is equals to mx plus b. So m here is our slope. So we have the formula for m. N is the number of our value. So we have n times the summation of xy minus the summation of x multiplied by the summation of y all over n times the summation of x squared minus the square of the summation of x. So, and our b is our y-intercept. So, the formula for b is summation of y minus m times the summation of x over n. So, in order for us to get b, we have to get first our m, or our slope. Since we already have our summation here, we can just directly solve for our m and for our b. So, applying the formula m, so n, so 10 times the summation of x and y minus the summation of x times the summation of y over the over n is 10 times the summation of x squared minus square of the summation of x. So using our calculator, this will give us a result of m is equals to 1.5. So since we already have our m, we can now calculate for our b. So b is equals to 165. 165 is the summation of y minus 1.5 times the summation of x all over n, or 10. So using our calcu, this will give us a result of 0. So since we have a value of 0, this will leave us with an equation of y is equals to 1.5x. So to verify our answer, let's let's plug in our x values. So let's say our x is equals to 2. So y is equals to 1.5 times 2, and y is equals to 3. So, and it is true. And as you can see in our table here, so if x is 2, then y is 3. So if x is 4, 1.5 times 4, and ry is equals to 6. And also, if x is 18, y is equals to 27. And you can check that on our table. So if y is equals to 4, I mean if x is equals to 4, y is equals to 6. And if x is equals to 18, y is equals to 27. So this means that our values are correct or accurate or precise. So next is coefficient correlation or correlation coefficient. So the correlation coefficient is a statistical measure of the strength of the relationship between the relative movements of two variables. The values range between negative 1.0 and 1.0. A correlation of negative 1.0 shows a perfect negative correlation, while a correlation of 1.0 shows a perfect positive correlation, while a correlation of zero point 0.0 shows no linear relationship between the movement of two variables. So we have an example here. So we have a positive correlation since it is positive 0, 0.4. So since our here, second, no correlation since RR is 0, and this is a negative correlation since RR is negative value. So we have a problem here. So we're just going to use the same problem that we used earlier with the linear regression. So the only difference is that we have the y squared column. So y squared column, so just going to square the y, 3 times 3 is 9, 6 times 6 is 36, 9 times 9 is 81, 12 times 12 is 144, and so on and so forth up to the last value, which is 30 times 30 is equals to 900. And then we get the summation, which is equals to 3,464. So to get the correlation or the R, so we have a formula. So R is equals to N times the summation of xy minus the summation of x times the summation of y all over the square root of the quantity of n times the summation of x squared minus the square of x squared multiplied by the quantity of n times the summation of y squared minus the square of the summation of y. So plugging our values, since we already have our values here, we can just directly substitute and plug in those values to get our correlation. So n is equals to 10, and summation of xy is 2310 minus summation of x is 110, summation of y is 165, all over the square root of 10 times 1540 minus 110 squared times the quantity of 10 times 3465 minus 165 squared. So using our scientific calculator, this will automatically solve this equation and it will give us in an R of 1. So therefore, we have a perfect positive correlation since our R is 1. So as you can see in our definition, if we have a correlation of 1, this means that we have a perfect positive correlation. So that's it for this video and see you on my next video. Thank you.